Hello students, hello friends, you are welcome to another time for this lesson. Today we are going to continue with our lesson of advanced practicals chemistry, and our topic, we continue with our topic is thermochemistry advanced practicals. This practical you can be performed by Form 5 students and the Form 6 students. So you're welcome to contribute from the first of this lesson up to the end of this lesson, and at the end I'm sure you're going to understand. If you have a previous lesson, we have learned the thermochemistry about the heat of the solution of sodium decahydrate and the sodium anhydrous sodium carbonate. So for today we are going to see another objectives to our topic. And the objective for today, we are going to learn the heat formation of magnesium carbonate. Objective: heat formation of magnesium carbonate. So this is our objective for today, and make sure you contribute from the first and to the end of this lesson in order you as a student to be able to understand. If you contribute to this lesson and then there is no any understanding, means you say you use a time. So don't use it or don't waste this time. It's very important to you, and it's very important to, as a Form 6, as a Form 5 student. I think we are together and you understand to this lesson. That is our objectives. So it means in order to perform heat formation of magnesium carbonate, we are going to use the question here of 2019 national examination paper, past paper of Nectar Form 6, and you'll be able to understand. If you have a paper, you can cross-check in order to be together here, to take a note and to solve that question. We have the following materials or solutions, chemicals. We have 1 molarity of hydrochloric acid. 1 molarity of hydrochloric acid. That is one. Number 2, we have magnesium metal, or it's called the magnesium ribbon. We have 0.2 gram. We have 0.2 gram of magnesium ribbon. That is magnesium metal. I think we are together. Another material we have 1 gram of magnesium carbonate. We have magnesium carbonate. Those are materials, and another material we have a thermometer. We have a thermometer. We are going to measure the heat, and we have a conical flask which we are going to use to perform an experiment. Also, we have hydrochloric acid solution. As I have said, 1 molarity. And I have also measuring cylinder. That is our apparatus. Those are apparatus. Our sample here, we have magnesium carbonate. This one is placed on a watch glass, and we have also magnesium metal. Magnesium metal is this one. So those we are going to use for our experiment, and then you are going to see how to solve this experiment. Okay. Apart from that, we are going to see formation of magnesium carbonate. Formation of magnesium carbonate. Magnesium carbonate, as magnesium carbonate, is formed by using magnesium metal plus carbon or plus coke and plus oxygen gas, we form magnesium carbonate. When you balance here, you see there is 1 magnesium carbonate, and here there is 3, 2. That is balanced. So we are going to reach here from our experiment, and then we will see the heat change or the heat of solution, which form or which is liberated through a reaction to see the formation of magnesium carbonate. Are we together? I think we are together up to this section. We go to the case of procedure. How to perform this experiment? The first experiment we have in 2 cases. We have the first case, we have the second case. It means case 1. Case A, we are going to use magnesium carbonate. Yes, magnesium metal. Magnesium metal react with hydrochloric acid. Magnesium metal react with hydrochloric acid. The product will be magnesium chloride plus hydrogen gas. You are going to see the gas liberated or given out within our reaction. And then we record the initial temperature for hydrochloric acid, and after reaction we are going to record the final temperature, and then we record the temperature change. I think for the previous lesson on introduction, we have talked about the heat change and the other concepts. Case 2, case number B, we use magnesium carbonate. React with the hydrochloric acid to give magnesium chloride, to give carbon dioxide, also to give water. That is the product for the second case or second experiment or procedure 2. That is our experiment. So within our question we have to show the formation of carbon dioxide and the formation of water. We have shown magnesium carbonate how it's formed, so we have to show the formation of carbon dioxide and the formation where oxygen is going to be, how oxygen is take place. So it means we have to show, in case of reaction, we have to show the also formation of oxygen or formation of water. It means water is formed by taking hydrogen gas. By taking hydrogen gas, react with the oxygen gas to give water. It means this first equation, second equation, that's the third equation. Another question, number 4, we are going to look the formation of carbon dioxide. This one. It means carbon dioxide, we take a carbon plus oxygen. We get carbon dioxide. So we have reactions or equation number 1 up to number 4. And for each, there is molar heat change. There is molar heat change. Those are given. When you look at that paper, there is a given for this one and for this one. So we are going to use these reactions to solve, to see formation of magnesium carbonate, how it is formed. So let's use a short time to note this, and then we are going to proceed. So by looking at the equations in case 1, case 2, and the formation of water, and the formation of carbon dioxide, when you balance here, it means there is, when you balance that one, this will balance with the, yes, this is balanced, and those are balanced. It means here is not balanced, here is not balanced, but hydrogen gas have 2 here, and the chlorine, hydrogen is chloride. Here there is formation of magnesium chloride. So this is magnesium chloride. This is magnesium chloride. I think we are together for this lesson. If you have a question, you can think, and then you will ask at your time. We proceed with our lesson. How we are going to see the formation of magnesium carbonate. So, in order to reach here, there is a reaction here is going to reverse, undergo reverse process or reverse reaction. So the first will be this one, 2 hydrochloric acid. The product will be 2 magnesium chloride plus hydrogen gas. The second is magnesium. So in order to, this magnesium carbonate should be in a product, so it's going to reverse, right? So when it reverse will be 2 magnesium chloride plus carbon dioxide plus water. The product is magnesium carbonate react with HCl. Do you see? I think you see. You can balance whatever possible. The third equation we have, it is still as it is plus oxygen, we give water. And the fourth reaction, go carbon dioxide. But each one there is a molar heat. Each reaction, it has a molar heat. We are going to see how can you perform, and then we are going to solve this experiment. I show these reactions firstly in order to understand about how to find the formation of magnesium carbonate. I think we are here today. So after looking this one, there is a compound is going to cancel. We have to reach here, formation of magnesium carbonate. So when you look at this one, it means hydrochloric acid in case inside of reactant we cancel with inside of product. That is one. Magnesium chloride will cancel with magnesium chloride. You catch this process. And another we have water will cancel with the water, case of product. Another we have hydrogen gas. This one will cancel with this one. And the carbon dioxide, in case of product, will cancel with in case of reactant. And then we are going to see which is main. The main, there is no. And the last we have, yes, that's there is, which remains, there is magnesium, there is carbon, there is oxygen. This is oxygen. It means this is 1, this is 2. That's why the 3 will be 3 oxygen. So in order to balance magnesium carbonate is this one. And then in order to balance we put here 2. It means carbon is 3 and here will be 3. Oxygen is 3 and here will be 3. Those are balanced. So this we reach here. That is the formation of magnesium carbonate. It means we are going to make addition of molar heat of this one plus molar heat of this one, 1 mole plus molar heat of oxygen, molar heat of oxygen, and then plus molar heat of magnesium carbonate. But understand that when this undergo reverse reaction is going to change also their molar heat. If it was negative, is going to be positive. I think for this one you have understood how to make reactions up to reach here. So we are going to another section or another part to see the experiment and then what was the answer for this question. Still here, we are going to see our experiment and then our procedure. Okay, after looking the reactions, now we proceed with our procedure one by one, case 1, case 2, then we solve our questions. So the first procedure, we measure 50 mils of hydrochloric acid. We measure with this one. This is 50. We put in a conical flask. Then we measure initial temperature. According to readings here is 27 degree. Initial was 27. Case A, initial was 27. Then we are going to add magnesium metal. So if we have this magnesium metal, we have to divide to increase the surface area, in order to make it, or to save the time for, or to speed up the reaction. Then we are going to see a reaction. It's very fast to dissolve, so you will note your heat or your temperature. Then you can stir, you can shake, make sure you dissolve. Make sure you dissolve. Okay, my solution is ready, clear. No another metal is present. So let's record our temperature. Is now 42. The initial, the final is 42. That is final. And you see there is hydrogen gas is given out. So heat change or temperature change means this minus this one will be minus 27 is equal to 15. Is equal to 15. That is case 1. Case 2, before calculating the molar heat, we perform case 2. Case 2 also we are going to measure 50 of hydrochloric acid. And then we pour in a conical flask, and then we record the initial is the same as 27, Then we pour magnesium carbonate. We pour magnesium carbonate. We pour magnesium carbonate. Also, you see there is hydrogen gas, carbon dioxide. There is carbon dioxide is given out. Anyway, make sure you record. Okay. 27. There is 28. There is 28 final temperature. Case 2. Case B, initial is 27, and now final is 29, sorry, that is 29. So temperature change is equal to 2, is equal to 2 Celsius, 2 centigrade degree. That is how you can perform experiment. It's very simple, it's very short. I think you have seen, they have understand. So now we are going to proceed with the calculate molar heat change. The molar heat or heat change and its molar. Just make sure you note this one, and then we go to calculations. So after calculating the heat change, or after performing experiment, let's solve our question. Case A, we find the heat change or heat. Our formula is equal to mass times specific capacity of water times heat change. Capacity of water is provided in our question, that is guided. And in order to get the mass, we have to use density. Density, we are sure that is the density of solution or density of water. So in order to get the mass, we have to multiply with the volume. The volume was 50 measured by measuring cylinder. So we take one density times 50 mils. We get 50 grams. Then we are going to use in our formula. So heat change will be negative 50 times capacity of water is 4.2 times 15. When we multiply, the answer will be 3150 joule negative. Do you see? You can put in kilo. It means when you divide by thousands, will be 3.150 joule kilojoule. After that, we have to find the molar heat of our experiment in case 1. So in order to get the molar heat, you have to find the mole. So mole is equal to mass, or molar mass. Mass over molar mass. According to our data, we have been provided the mass of magnesium ribbon. We have provided with 0.2. So 0.2 divided by molar mass of magnesium is 24. 0.2 divided by 24 is equal to 0.01. So when you divide with this one, molar heat is equal to this one, 3.15 divided by 0.01. 3.15 divided by 0.01 is equal to joule kilo per mole. And this is negative. That is in case 1 or procedure 1. Do you have understood? Do you have understood? Hello student, do you have understood what it is? Now we are in case 1. Yes, we go to case number 2. So in case B, also use the same formula, but our temperature is this one. Then you are going to calculate as a first case. Our mass, the volume is the same, so will be 50. This is 1, and the 50 will be 50 grams. So directly we are going to use negative 50 times 4.2 times 2. The answer will be 50 times 4.2 times 2. The answer will be 4.2 joule. When you divide by thousands, the answer will be 0.242 joule per kilo or kilojoule. And then after you have to find also the mole. The mole for the second case means the mole is the same, mass of a molar mass. You have been provided magnesium carbonate 1 gram of a molar mass 84. So mole will be 1/84. You see? It means magnesium carbonate. This is 24 plus 12 plus 48. It means 24 plus 84, yes, 84. Divide 1/, is equal to 0.01. So heat change was this one. So this per mole is equal to 0.42 divided by 0.01. 0.1 will be 42 joule per kilo per mole. So when we call for the previous reaction, so now we have a molar heat for magnesium for the first, right? We have this one for hydrogen. We have been provided for carbon. So now we are going to to make addition. This is negative, but remember that this undergo reverse reaction or is reversed. So it means from negative is positive now. So plus this one is 0. So when you take your calculator here, we see the final answer. So we take this one, negative 378. So we take this one, negative 7 plus negative 394 plus 286 negative 78 plus negative 394 plus negative 286 plus 42. The answer is equal to negative 1 joule per mole. That is heat formation of magnesium carbonate. This obtained on the first calculation, there is some errors obtained by taking 0.2 divided by 24. This is mole. When you divide by this one, you get this one. When you divide by this one, you get this one. So you can repeat to see our data, then you can solve it to understand more about our lesson. That is calculation. There is some errors due to the efficiency, due to the speed of our calculations. So apart from this one, thank you for your contribution from the starting up to the end of this lesson. That is how to calculate heat formation for magnesium carbonate. Thank you for contribution. We'll meet another time for another lesson. This was the Thermochemistry Advanced Practicals. Another time we'll be together here. Thank you. Thank you more. Another time, another day.